ఇలాంటి చాలా ఉన్నాయి ఇంకా.
Hi everyone. I think audio, video, everything is clear. Quickly confirm in the chat. If something is not clear, let us know. All set? Okay. It seems everything is audible. So now we are here to learn some DC machines concepts with the help of interesting and good MCQs. Okay. Without further ado, let's get into the first question. So before we go to the questions, let me just show you the questions what we have. I'm just taking over the questions, all the questions what we want to see. We got pretty well questions in this, some numerical type questions also, without actually using a calculator, how to handle that numerical type questions. We also got that also in this. Okay, so yeah, it's going to be amazing the way it was. And in the previous session, we really had a good interaction. You've been answering the questions, you've been marking the options. So I expect the same now as well. Okay, so we got some easy questions and some really good questions. Okay, so we'll try to see how many questions we can solve. Accordingly, we'll see. Okay, I got, I think, a huge number of questions. So let me just start with the first one. Bang. So you know the drill. Timer will be running. So you need to mark your answers. Okay. Yep. Here you go. Timer is already running. The first question, easy one. I think everybody will answer this. Yeah. Why are you taking so much time? Good. We got a quick answer. Quick answers, couple of answers we got. You're right. Good. So at the beginning, we're having easy ones, but slowly we'll move to the tough ones. I think 20 seconds is more than enough for this question, I guess. We don't have to go for, we don't have to wait for a longer time. So I think everyone answered correct. So this is for all of you. Everyone answered correct. Good one. So answer is kept smaller. Okay. For a DC machine, obviously, we're talking about DC machine. To have a stronger magnetic field, because the moment air gap is less, sometimes in case of synchronous machines, we purposefully keep larger air gap. Okay, we keep larger air gap purposefully. But in case of a DC machine, we maintain smaller air gap, because smaller the air gap, flux is equal to MMF by reluctance S. Reluctance S, which is, I would like to call this one as a magnetic Ohm's law. Okay, EMF by resistance we'll call it as electrical. Magnetic Ohm's law is MMF by reluctance. If air gap is less, reluctance is less, so flux is high. So stronger magnetic field if the air gap is less. So the answer is A. Absolutely right. So next one. Here you go. You go for the next one. See guys, you have to mark the option, it's enough. Karthik Kumar. Yeah, Karthik Kumar is marked his option as well. I don't know why you guys got a mixed answers. Some people are saying, I think by mistake, Praveen must have given B. Okay. I think all of you have answered this correctly once again. Okay. All of you answered correctly. So good. Keep it up. So it's pretty simple one. Rotating part. See, a rotating part is called as a rotor. Naturally, students do ask, sir, what is a stator in this? The one which is stationary is a stator. The one which is rotating is a rotor. You cannot really say outside is a stator or inside is a stator. Can you really say that? I'm asking you. Outside is stator or inside one is stator? You cannot really say. Yes, you cannot really say. Turn above. Look above. There is something rotating above you. Fan, ceiling fan. There outside is rotating. The outside is a rotor. Inside, which is stationary, that's a stator. Okay. So now it is very specific. DC motor. Regular DC motor, not a BLDC or any other special motors. Regular DC motor. The rotating part is, inside part is rotating. That's what armature. We keep armature rotating. Rotating armature is tougher, heavier, complicated. Am I right or not? Rotating armature is easy or rotating field is easy? Tell me, I'm asking you. Rotating armature is easy or rotating field is easy? Yep. Based on this, there are some interesting conclusions. Yes, absolutely. Rotating field is easy. Yet, we rotate armature. Rotating armature is complicated, but in case of a DC machine, whether it is a motor or generator, if it is a DC machine, we prefer to rotate armature. If not today, earlier at least. If not the advancement of, along with the advancement of power electronics, earlier we prefer to rotate armature. Why? Can somebody tell me why? Why is it so? Why? Absolutely, absolutely amazing. So you're absolutely rocking. Kranti Kumar, you're absolutely rocking. Good. Yes, commutation problems in rotating. Commutation problems is not commutation. To get a commutation effect, we need a commutation to happen. Conversion from DC to AC. To give always inside the armature AC, though input supply is DC, we have to rotate. Armature is forced to stay on a rotor in spite of being difficulties of rotating armature. Just to have a commutation. Just to have a commutation. If commutation problem is not there, commutation requirement is not there, it's not a problem. Commutation is a requirement for me. In case of a DC machine, it is a requirement. Commutation is a requirement. Okay. If that requirement is not there, then I can rotate field. That's what happens in case of AC generator. In case of AC generator, in case of DC generator, what's the difference? In case of DC generator, we want commutation to happen. That's why armature is rotating. I think this is a key point, guys. This is a key point. I hope everybody should be, everybody is clear on that. Okay. If that is clear, let's move to the next one. Bang. I think again, this is a 10-second question maybe. Quickly, thoughtfully, no hurry. Quick, it doesn't really mean that you need to be hurry, okay? No hurry, but be faster, be quicker. We're getting some mixed answers. Let's see what others got to say on this. I don't know why you got confused on this simple question. 8 more seconds. 2, 1. Time's up. So it's my turn. What's the effect produced by the electric current in an electric motor? The purpose of current in electric motor, you take any electrical motor, the purpose is to generate the flux. flux. So main cause is generating flux. Okay, magnetic effect. But it's not only magnetic effect. There'll be some losses. So there'll be some heating effect as well. There'll be some heating effect as well. So magnetic effect as well as heating effect. The current will cause both. Even in permanent magnet type DC motor, even in permanent magnet type DC motor, still the current will create magnetic effect. Tell me how. Why do you require, in case of permanent magnet type DC motor, why do you require current to produce flux? Tell me. Tell me, I want to hear from you. At least some hint in a smarter way. If you can respond, it's good. This is one of the key aspects of entire electrical engineering, which you have to know, obviously. I'm saying permanent magnet DC motor. Here, our objective is not just to mark the options. Our objective is to build the concepts with the help of questions. Okay. Yeah. So the question is, how come in case of permanent magnet type machine, why current should produce magnetic effect? Yeah, I'm waiting still. Back EMF, I'm saying back EMF is equal to, if it is a back EMF, somebody is answering back EMF, phi Z NP by 60A. So this phi is from the permanent magnet itself. From the permanent magnet itself, we are getting phi. So, I mean, why? Yeah. Armature reaction. See here, one thing. You guys are giving mixed answers. Let me put it this way. Key point, guys. Remember this. To have electromagnetic Faraday's law to work there, to get a Lorentz force there, okay, to get a Lorentz force there, you need two fluxes. To generate EMF, you need two fluxes. One flux is not enough. One flux is not enough. Two fluxes are required. Interaction of both the fluxes will give you the torque. Whenever you see the torque equation anywhere there is a Lorentz force, means torque is always proportional to two phi's, phi 1, phi 2, and to be more precise, the angle between sine lambda, let me call, the angle between phi 1 and phi 2. This is the key equation for any electrical machine, be it a motor, be it a generator. This will work. Okay. There are some exceptions where reluctance torque is coming. That's an exception, a little bit of exception, but most of the motors work on this. Two fluxes must be present. So be it a permanent magnet DC machine, yet you require this current, which is responsible for your magnetic effect. I hope it's clear. Give it a thumbs up if it is clear. Give it a thumbs up if it is clear. Is this clear? Everyone? Is this clear? Okay. Good. See, you have to tell me in the chat at least, right? Okay. Otherwise, how will I know that? Next one. Your timer is running. So if you have anything to ask, you can ask. So no doubts on this. Go for the second question. Next question. I think there will be a trap. You guys get trapped. Already one person got trapped. Lokesh, check it again. Kranti Kumar, check it again. Check it again, guys. Look at all options. Look at all four options. Look at all four options. Don't be immediately answering the question. Don't be in a hurry. I told you, right? This is an interesting one. Thoughtfully, you mark your option. Thoughtfully. I expected, most of you would be giving right answer, but we got mixed on this, mixed response on this. It's okay. Time's up. Let's get to the analysis. Function of a commutator in a DC generator. It is more precise, it is about DC generator. Everybody would say, if it is a DC generator, the purpose of a commutator is to convert AC to DC. Remember one point, inside a DC machine, I'm talking about a machine, motor or generator, inside a armature of in any DC machine, armature current is always what? AC. Inside the armature, current flowing is AC, not air conditioner, alternating. Now, I want a DC output, not AC output. So, I'm using a commutator to convert AC to DC. So, now this option pretty much says that to change alternating current to direct current. So, you would answer this, but wrong. See how nicely the question is framed to trap you? How come it's wrong? Tell me. How come it's wrong? Improve commutation, what are the methods to improve commutation? Try to recall, build the concept, what are the methods to improve the commutation? Two commutation methods, improving techniques, resistance commutation, EMF commutation. Okay, so one is by adding interpoles. The second one is by adding carbon brushes, high resistance carbon brushes instead of low resistance copper brushes. Okay, so that will improve the computation. Okay, and compensating winding also will improve that. For easy speed control, how does it, commutator will have an impact on speed control? So the only left over option is this. Now you would obviously say, so how come A is wrong and D is right? See, if you really know the operation of your commutator, you will definitely understand that if you don't connect any load, okay, you're not connecting any load, no load you're connecting. Check the voltage at the terminals of the generator. If you have a generator, after commutator, you have two terminals. At these two terminals, don't connect any load, check the voltage. You will get a DC. You will get a DC. So once the voltage is DC, it is converting AC voltage to DC voltage. That will give the current DC. That implies further. So you are getting a voltage DC, and the moment you are connecting a load, it is driving DC current. Okay. So basically, one would ask this, and this is one of the popular questions. Voltage will give the shock or current will give the shock? Tell me. Electric shock, voltage will give shock or current will give shock? Tell me which one. Mark in the options. Similarly, here voltage is the origin or current is the origin. So if I say voltage is the origin, I would say that because voltage is a driving force to move the electron or move the charge. Okay. So voltage, that leads to current. Okay. So for the shock reason, people are saying current is the one which gives the shock. That's not actually true. Okay. You will feel the shock because of the current. Remember this. This is a key point which you should take away from this. You are feeling the shock. You are feeling the shock sensation because of the current. But the current is flowing due to the voltage difference, not the voltage. What's that? Voltage difference. So I would say because of the voltage difference, current is flowing. And as current is flowing, you are feeling the shock. So obviously both are inclined. You have to justify this nicely. Okay. So if there is no voltage difference, why will I have the current? And to have your answer, absolutely right. Because current is flowing, that's why you're feeling a shock. If there is no current flowing through you, there is no feel of shock. Okay. And why current is flowing? Because there is a voltage difference. Okay. So voltage difference is the cause to create a current, and because of the current, you are feeling the shock. Okay. Yes. Good. Next one. I think for this is clear. Anything else? Anything else? Anything else? So we got a question from Sampath, if somebody can handle it. Try to see this. Why we don't study by including Excel? Okay. So in case of DC machine, I think he's asking. Yeah, absolutely. It must be for a DC machine. So we do study. Don't think that we don't study inductance effect in case of DC machine. We do study. Inductance effect is there in case of a DC machine because current flowing inside the armature is AC. There is inductance effect, but that inductance effect will be included during transient when you're studying a dynamic analysis of DC machine, which you will study in post graduation. There you have to include that inductance effect of a DC motor as well. Now the analysis, whatever you are doing, they're all steady state analysis. At steady state, there is no effect of inductor for a DC supply. Okay, but during dynamics or during transient, you have to include the inductance as well, and you will include inductance as well. Okay, so good point, by the way. That's what you have to see what you're dealing with. You're dealing with the steady state. That's why you're not, you don't normally study that effect. Okay, in easy case. This is easy case, easy one. But there is something interesting analysis behind this as well. Let's see this. We already got an answer. Somebody's marking answer. But analysis, we'll discuss something interesting in this question as well. Okay, as I told you, our objective is not to mark the option, right option. Our objective is to analyze the remaining options, why they're wrong. That's what we'll be doing. Wow, good. Everybody answered correct except few guys. I don't know why. Madhu, what happened? What happened, Madhu? See, these kind of things, you should be clear. Madhu, I think you're a diploma guy. Sampath, what's going wrong, guys? What's happening? That's not expected. Time's up. It's quite surprising to see a couple of wrong answers on this question at least. Okay. In a DC motor, the iron losses occurs. I think you must have misinterpreted the question. Maybe, I'm not sure. Because you both are good, Madhu and Sampath, but yet you got a wrong answer. I don't know. The iron losses occurs. Iron losses, see this. I think somebody was saying, why don't we consider inductance effect? That's what will come here. We'll see here. Iron losses means eddy current losses plus hysteresis losses. Am I right? So tell me, eddy current losses and hysteresis losses, are they present in case of a DC machine? Because the DC, in case of a DC, what's the concept of eddy? What's the concept of hysteresis? I don't think there is a concept of eddy and there is a concept of hysteresis. There should not be, rather, because it's a DC. Am I right? Am I right? Yes or no? Absolutely. It appears to be. But just because I told you in case of a DC machine armature, the current flowing is AC. The current flowing is AC. Okay. And steady flux is there. I have shown you with the animation in our regular class. You can, I think, also check the free videos also from the PiSquare app. There also you will have these animations. Okay, where steady flux is there, armature is rotating. So armature will also induce EMF, not armature conductor. The silicon steel itself is having current. So that's why you're laminating armature. Why you're laminating armature? To reduce eddy current loss only, right? And as inside the armature, the current is AC. So basically, armature is present inside the change in flux. It's a kind of a thing because armature is rotating, flux is fixed. So when something is rotating, something is fixed. There is a relativity between these rotating and a fixed one. So there is a hysteresis as well. Iron losses are still present in armature. That's why you are using silicon steel to reduce eddy current losses. And furthermore, you are using steel to reduce hysteresis losses because it has a less hysteresis curve. Armature is right answer. Now you may ask the question, sir, why not yoke? What's the purpose of yoke? I think the animation what I have shown in the app, I think it pretty much shows very clearly. Cover, it's a protection cover and a magnetic field provision, and you are giving a DC current to produce a flux. The flux is steady flux. Yoke is also steady. There is no relative speed between yoke and flux. Any relative speed? No relative speed. So why eddy current, why hysteresis loss present in case of yoke? No. In case of field, no. Now you may say in case of pole shoe, there is a chance that eddy currents may produce. Okay, but option is not there. Okay, so this is the right answer. I think this is pretty much clear to all of you. Iron losses in a current core. Iron losses, I mean, Sampath, what are you trying to ask? Iron losses in a current armature core. Yes, absolutely. Armature core, iron losses will occur. That's why they are called as core losses, right? Are we good to go to the next question or any further queries on this? Nagadeep is saying magnetizing, demagnetizing continuously. Absolutely, dear. You're absolutely right. Okay, magnetization, demagnetization, this happens even in case of when it is rotating. When it is rotating, steady flux is rotating, magnetizing, demagnetizing will happen. Okay, continuous change in flux. Yes, absolutely right. Hysteresis coefficient, good, 1.6. Okay, I think we're all set. Let's go to the next one then. I think this is also easy one which you'll be able to answer this. Try this out. This is flowing. Okay. Do you guys got some questions? No. Anil is saying A. Gopalakrishna B. Sampath B. Okay. Why mixed questions? Mixed options. Anyways, you got 15 more seconds to go. Two, one, back. Time's up. I think mostly you guys have answered B. Yes, you're good. See here, the EMF of a DC generator depends on main dependency. What you have to see that, of course, commutation. There is a slight drop because of improper commutation, because of the reactance voltage drop and all. There is a slight change in EMF because of the brush contact drop. Yes, they are true. I'm not denying that. But the more appropriate one out of all these is definitely the speed. Has a great impact, right? Speed is the one which is having a great impact. Higher the speed, higher the EMF. Okay. Anyways, let's get to the next one. If everything is clear, we're moving to the next. I think we're good on this. Anything to ask on this? No, right? Okay. Only for the first question, everybody answered correctly. For all next subsequent questions, we're getting mixed answers. Okay. So if all questions are right, you'll get the blasters. Team will blast you some pop blasters. Okay. So for that, everybody should be right. 15 more seconds to go. Oh, come on, yeah. We've seen just now. Anyways, time's up. Time's up, but this is not expected, okay? We have just seen this. A simple method of increasing the voltage of a DC generator is decrease the air gap flux density, increase the speed of rotation. It is said increasing the voltage. Definitely the convenient method, simple method is pick up the speed, increase the speed of rotation. We just saw that. Huh? Yet I got some people saying D. That's a strange thing, huh? Even some people say A as well. Okay. Now the popular one, interesting one, good one. Try this out. Try this out. Try this out. I think you can say at least I'm expecting 50% of right answers on this particular question. Go. No response yet? Nagdeep, you have to send just once, not twice. DD or AI will not detect DD. Okay, it will only detect D. Okay, time's up. Time's up. Arvind is trying to say something. Arvind is trying to say something. Anyways, so we got mostly people are saying C. Okay, good. Mostly people are saying C. C is right. It's not because of mostly people are saying C. Keep 1 point in your head. This is another takeaway. Another takeaway from this lecture is this session is careful. This conductor and this conductor, these two conductors are exactly in the middle of the pole phase. Am I right? These two conductors are the middle of the pole phase. These are pole phase. Are we right? So these are the middle. These also for this pole phase, these are middle at the middle. So whenever the conductor is at the middle of the pole phase, that will induce maximum EMF. Okay. So this simple line, write it somewhere, this will help you immensely. In AC, wherever you have to use, you can use it. Okay. Flux and conductor. It's not conductor, dear. That's the wrong thing. Flux and conductor, angle between flux and conductor is 90 degrees. How can you say that angle is 90 degrees? Conductor is always 90 degrees to the, conductor is like this, flux is like this. Maybe conductor at this position, flux is like this. So for all these conductors, see, conductor is this way, E conductor, flux is this way, flux is this way, right? Conductor is this way. Is this not 90 degrees? Yes, it is 90 degrees. It is 90 degrees. Okay. So flux and conductor 90 degrees, that's not the right approach of analyzing it. Okay. Yeah, I think Nagdeep has an answer for this. Nagdeep. Yes. He is right. In a simple way, he said that this flux, rate of change of flux, the change in flux is maximum. Okay, the cutting action is maximum, hence the induced EMF is maximum for this. Okay. Anyways, I think this is clear. Option C. Anyways, keep this point in your head. When conductor is at the middle of the pole phase, EMF will be maximum. This line, superb line. Okay. Next one. Next one. Here you go. I think for the previous question, the analysis, better analysis is there in this question. Okay. Okay. Good, guys. For this question, everyone marked it right. Okay, good. Keep it up. So in any DC generator, the EMF generated in the armature is maximum. That's what exactly I think Lokesh has stated that. He said that line to be more precisely. So EMF induced is equal to N d phi by dt. Okay, so d phi by dt is maximum. So induced EMF is maximum. So rate of change of flux linked is maximum d phi by dt. That's what rate of change of flux. dt, that's what rate of change. In what? Phi, flux. Whenever you have dt, denominator dt, with respect to time, it's changing. So this increases, this increases. This is high. If this is high, this is high naturally. So B is answer. Okay, very good. We got analysis as well from Lokesh. Okay, so let's go to the next one. I think any questions on this? Anything to ask? No queries? Good. Next one. Let's go to the next question. Easy one, right? All are right, but less answers. I expect a little more. Good. All are correct. Nice. Everyone. That's good. Others also. Dummy coils. Popular questions, I think. How come you miss it, guys? Anyways, whoever said, and that's absolutely right. Well within time, you answered it correctly. The dummy coils in a DC machine is used to eliminate reactance voltage. Reactance voltage. Why reactance voltage? That's what the answer for your previous question, some of your previous question. Inductance effect is there inside the armature. Because of that, inside inductance effect, there is some induced EMF, self-induced EMF. That's what we'll call it as a reactance voltage. Dummy coils is not for that. Armature reaction improved technique is not this. This dummy coils are used in which winding? Tell me that. These dummy coils are used in which winding? Only in one type of winding these dummy coils are used, not in all type of windings. So what is that? Which type of winding dummy coils are used? Huh? Yes, Sampath, he has already made the answer. Amazing, Sampath. That's good. That's good. Before I asked the question itself, he expected, I think, my question. He even answered before my question. Good. No voltage induced in the dummy coils. Wrong. You're wrong. Okay. Gopal Krishna, you're wrong. No voltage induced in dummy coils is wrong. Yes. Voltage is induced in the dummy coils. No current is flowing in the dummy coils. There is a difference. Dummy coil is also a copper conductor, just like any other conductor. Okay. But is not included in the connection of the winding. But after all, it's a conductor, If someone asks you whether induced EMF is there inside the conductor or not, oh, absolutely yes. It's a conductor. It's in the presence of magnetic field. It will experience the rate of change in flux. There is a Faraday's law. Obviously, it is valid. EMF is induced. Okay, I hope you got the point. Okay, good. So answer is armature reactions over. It is for mechanical balance. It is for mechanical balance because in case of wave winding, some conductors, all armature slots are not utilized for wave winding and lap winding. Armature core, we normally, it's because of our laziness. Yes, we have to use dummy coils because of, it's not laziness, design aspects. I will design armature core irrespective of the winding. Careful with this point. Why dummy coils are used means, I design suppose some number of 30 number of or 24 number of 32 number of slots I made. Okay, I put it, I just manufactured it, I kept it in my store. Now you have come to me to build lap winding, I will sell it to you. And you have come to me for wave winding. For wave winding, this 32 number of slots are extra, you need maybe 30 number of slots. I'm just giving a random number. Okay. But I don't have 30 slots armature core. Okay. So what you'll do, you will take this 32 slots because if I had to design again, if I had to manufacture again 30 slots, it will be costly affair for me. Okay. So I will sell you 32 slots armature core to you. Then you will keep 2 slots empty. You will keep 2 slots empty. You will not keep any conductor in that. So absolutely, if one side it is lighter, one side it is heavier filled with conductors, there is a mechanical imbalance. You want to make the uniform mechanical balance. So we'll place conductors there, but no connection is made to that. Okay, so they're purely for mechanical balance. Okay, nowadays if you have a popularity of, no sir, I can build a 30 slots armature core, no problem with that, then there is no point of dummy coils. Okay, earlier case they used to have this kind of a problem, so they used to resolve it this way. Okay, I hope you got the clarity on this specific point of dummy coils. Why do we need it and why do we especially need for wave winding? Okay, next one. Shankar is saying, please go fast. Do one thing, Shankar. Watch the broadcast. Once the live is over, try to watch the broadcast in 2x mode. I think that's right for you. Because I have to explain a concept, right? I cannot just keep on moving. Otherwise, I'll keep marking options. Like, MCQs. You appear, you go to our website, our app, enjoy the free test. Okay. In 40 minutes, you will be able to appear 40 questions. Bye-bye. Okay. Mixed answers again for this. Oh, how come, man? For this also mixed answers. That's not really expected. This is pretty bad. Really bad. Because this question also we're getting mixed options. Not happy. Anyways, time's up. Brushes are used in electrical machines. It is said in electrical machines. Be it AC, be it DC, electrical machine means don't think that it's only DC machine is electrical machine, AC machine is not electrical machine. Both are electrical machines, right? In AC also we use brushes. In which AC machine? Induction, slip ring type, slip ring and brushes. Yes. The main purpose is to provide a path for the flow of current, because you have to connect, whenever you have to connect a rotating body with a stationary body. Let me repeat. Whenever you have to connect a rotating body with the stationary body electrically, anywhere, so far the only option is, of course there are induction effects and all, but the best option, only option, whatever you have so far, even today's world, is called brush. It is not to dust the deposits in the commutator, not for cleaning purposes. Okay. Do you know one point why the name brush is given? This is really an interesting story. Okay, real and interesting story. I think in our lecture we will get that. Why the name brush is there? You could have called something else, but brushes means the paint brush, toothbrush. This is what we'll see. But do you ever see that? Did you ever see that brush which is used in case of DC machines? That's not like a toothbrush. That's not like a paintbrush. But still they are calling it as a brush. Why? Already their details are there and the free videos there. They are trying to watch it. You will get it. Okay. So sparkless commutation will use carbon brushes. Okay. It's not sparkless commutation, reduced spark, improving commutation process, but it is asking about brushes. Okay. So prevent sparking during commutation is not the purpose of placing a brush. The purpose of putting the carbon brush could be this in case of a DC machine. Okay. But normally brushes are meant for this purpose. Answer is B. Okay. Prevent overheating. It will cause the heating. Okay. Friction, rubbing action, there is a heating problem. No. Okay. I think this point is also clear. Somebody is saying this. Okay. Sparkless commutation. Lokesh is saying that that's for carbon brushes. But in general, it is for brushes in an electrical machine. You need to be clear with the question, dear. See, you all know these aspects, yet you fail to mark right answers. What kind of knowing you know? You actually don't know what you know. You have to really know what you don't know. Is it confusing? Just rewind and watch it, you will get it. Okay. Next one. Oh, this is, I think, there is no big deal on this specific question. Easy one. Okay. Everybody will be able to answer this. I think everyone will be answering this correctly. If you're not answering this correctly, jump off from the building. Okay. Good. Nice. I think in half a time, we got the right answer. Okay. In half a time. In a DC motor, input voltage, whatever you're giving, that is equal to EB plus IARA. Careful, guys. If you understand a motor, careful. Powerful tip I'm giving. Powerful tip I'm giving. To get a generator effect, to get a generator equations, all you need to do is replace IA with minus IA. That's it. If you replace IA with minus IA, you will get all generator equations. Okay. That's it. That's a powerful tip of the day. Another powerful tip of the day. I think we shall move to the next question, right? Good. Let's see this one. Previous one was easy, so you answered it. But this one is not that easy, not that difficult also. Cool, let's see. Let's see. There's only, very less people are responding, man. For such a simple questions also, only few people are responding means what? Bhagwan can save you. Even Bhagwan won't save you. You try to give at least your opinion, then you will get to know this is wrong or this is right or something, whatever, you'll get to some conclusions. If you don't just mark it, then how will you know whether you're right or wrong? Okay. You're not going to lose any marks if you're wrong, right? So mark it. Cool. And mostly we got B. B is mostly preferable answer, but sadly, that's wrong. Time's up. That's wrong. B is wrong. It is said, carefully here, it is said DC voltage applied to the armature of a DC motor. It is for a motor. DC, you are applying it. The current flowing in each armature conductor. In each, how can you are getting this, baby? Huh? You are giving input voltage constant. On what basis? It will be like this, huh? See, commutator is there. Converting DC to AC does not mean that it will do like this. Okay. So first thing is clear. Armature current is AC. I told you this point very specifically. This is DC, wrong. This is DC, wrong. Why they are wrong? Because they are DC. We know in case of armature, inside the armature of a DC machine, be it a motor or generator, it is AC. So either of these two. Now at least tell me which one among these two. Now at least tell me which one among these two, C or D. Now at least half portion is clear for you. 50-50 options are over. Now this is left for you. Try this out. Flat top. Somebody is saying flat top. Your answer may be right, but your thought process is wrong, dear. Okay. Flat top concept is for different concept. It is for armature conductor current, each conductor current. Square wave. See, this is not flat top wave, this is a square wave. Okay. Anyways, flat top is a flux. Main field flux shape is a flat top shape. Okay. Anyways, this is right answer because sometimes it is here. Again, when commutator changes its segment change to another position, it will be opposite. For this clear animation with 3D animations, I have explained you in the class. Okay, even on YouTube itself, it's there, dear. That's one of our popular videos. Armature reaction concept and commutation is one of our popular videos on YouTube. You go through it and check it. You'll get some amazing, powerful animations. I think once you watch those armature reaction commutation videos on YouTube from PiSquare channel, you will never get any doubt on armature reaction commutation for sure. And if you get those questions also, those will be juicy questions. You can pretty much easily answer those questions. Anyone can answer that. Okay. And it's popular and most of the teachers also recommending that. I'm glad to hear that. Anyways, moving on. These answer for this. Next question. Okay. It seems like a numerical type question. Yes, of course it is. It's not it seems like, it is a numerical type questions. But you can answer it without calculator. Okay. If you want to use calculator, it's okay. But I'm going to explain this without using calculator. Okay. But if you want to try with calculator, you can try. But I want to answer, by the way. Give me the answer. Let's see. Logesh saying, what about sine wave? Sine wave is wrong. I got a signal from my friend that 1 hour is up. So we'll wind up with this question. I told you, right? You're free to use calculator. I'll give some interesting tips based on this. Sampath has shared his view, his basis, but there is a little flaw in that because it's not EGDA. Why you're using EG? EG is used when generator case. Ha, this is the proper one. With that EB equation, it's not EG, EB, that's it. Okay, and you're absolutely right. At least, Sampath, you shared something. Okay, this for you. Wow, Nagdeep. Have you used calculator, Nagdeep? Anyways, time's up. Good. So only Nagadeep has given answer, complete answer, and Sampath has shared a formula, powerful formula. Okay. So let's look into this. The armature, see, whenever, definitely for a DC machines, armature reaction is a key concept and speed control is a key concept. Okay, these two are the key concepts in DC machines. Okay, so you have to solve more number of questions on armature reaction and speed control. If you have a good hold on these two, remaining things are informative things. You have to know it, that's it. You don't have to apply much of your brain. If you know it, you'll be able to answer it. But armature reaction and speed control, you have to apply your brain. Okay, so keep this noted. Now, whenever you see speed control question, or Sampath has said, so this equation, you have to keep that equation in your head. Means E1, EB1 by EB2 is equal to N1 by N2 into phi 2 by phi 1. That also you have to keep. Okay, so any speed control question is given, irrespective of what is asked in the question, keep this in front of you. Write this in front of you, irrespective of the type of a motor, irrespective of what is asked, write this equation. Most likely this will be helpful. Okay, it is said shunt motor armature resistance is 0.4, no load armature current is 2 ampere. Now the question is, without calculator, how to solve this? That's what I'm trying to say. Okay, so here flux, no change is made on the flux, so this is constant 1. EB1 is equal to V1 minus IA1 RA by V2, no V2 V1, same voltage, right? Same voltage V1 or input voltage Vin minus IA2 RA is equal to N1 by N2, N1 by N2. Now just plug the numbers here. What's the input voltage? Input voltage is 200. I place 200 minus 0.4 into 2 ampere. How much is that? 0.8. Okay, this is 0.8 by same 200. Okay, I'm just placing same 200 here minus IA2 into RA, which is 50 into a 0.4. How much is that? It's something close to 20. 4 5 4 20. Yeah, it's 20. Is equal to, we got N1 is how much? N1 is given as 1200. Good. So you have to figure it out, the denominator. What is this? That's it. Now take an approximation, guys. This is not a fill in the blank question. Rather, this is options. You have options, multiple select questions, multiple choice question. So for that, you can pretty much guess it. This 2 minus 0.8, let's take it as 200 itself. Okay, and this is 180, it's fine. It's 180. Okay, so this gone, and here let's cancel this, or let's do it different way. 0, 0 gone. This is 6 here, 20, this is 3. Okay, so 3 here, almost 7, 6.9 something. Okay, 70, I mean, approximately I'm doing that. So definitely this value will be less than 70. Once you cancel this into this, you will get less than 70. So 70 into 20 is 1400, means less than 1400. So which of the options are matching less than 1400? This is wrong, this is wrong. Possibly this, possibly this. Okay. Now, which one among these less than 1400? So these two are the options. See, at the load, some load, you're having 1200. At no load, definitely not 1200. Because you know the characteristics are like this. Torque versus, or IA versus speed for a shunt motor. So definitely at this current, if it is 1200, at less current, it will be higher than that. Okay. So what I mean to say is definitely this is also not answer. This is a possible answer. Okay. You don't have to get into the much of calculations. You can approximately mark it. Okay. Did I take ratio reverse somewhere? Which one take ratio reverse? Okay, fine. EB1, then how come I got a right answer there? EB1 is a shunt motor under no load. This is this. Okay, fine. You're right. I think you got the process right. I'm talking about the process here. The formula wise, you can take this because this aspect is unknown. This aspect is known, means this is known to you, this is unknown to you. Okay, you got the idea. Basically idea is clear, then you can do the math. Okay, good point by the way. Okay, Kranti Kumar, good. Now let's finish up with 15 questions. Okay, so this is the 15th one. Try to answer this, then we'll wind up the session. Good. I think a simple one. Everybody's answering. Same. Good. So first one you answered, all of you answered correctly, and the last one also you're doing good. Anyways, keep it up. I think most of you answered correctly. Speed of a DC motor is directly proportional to the back EMF, inversely proportional. Just now I said the equation. EB is equal to phi ZNP by 60A. ZNP by 60A. Okay. So N is proportional to EB by phi. Proportional to back EMF and inversely proportional to flux. Absolutely right. Absolutely right. Okay. So yes, we even got right answers even after that. Everybody's answering right. Good. Yeah, both hands right. You can also practice it. If you practice it, it will work. Okay, guys, I think you got pretty much cleared about this. Any doubts on the discussion what we had? We can have it. Otherwise, we're happy to end the session. See you in the next session. Anything further? So start your preparation. I think you all accessing the app where you have free content is there, free practice tests are there. Okay, so try to handle that. Tomorrow's session, what kind of information you want? So tell me, guys, what sessions you want tomorrow? Which session? So previously we dealt with circuits, now DC machines. So I'm planning to synchronous machines. I mean machines part only, maybe transformers, induction, or synchronous. So whatever you want. If you have any options, you give your options. Otherwise, I'll go with my choice. But definitely machines. It's going to be machines. Previous year questions. Already we had a lot of previous year question series here. Okay. If it's a previous year questions, I cannot sequencize those things. Already we had done, on these subjects, machines. I think more than 60 videos are there, I think, on machines and in all previous year questions. Playlists are there. So you can check that. Okay, sure. By the way, all of you from which place, tell me? What's the location? You guys are from different locations. I want to know your location. You're from which location? Everybody? Everyone? Signals and systems. I need to bring some other faculty for that. Power systems, standard questions. Power systems, yeah. For power systems, there is no better question than CL Vadva. Okay, and our team has worked with beautiful explanations for CL Vadva. Everyone is enjoying that question test series. Okay, CL Vadva test questions are there in the app. Almost I think 600 questions are there. So their detailed explanation is there. What are the possible wrong answers? I mean, if you can focus on that CL Vadva tests which are present in the app, you will master in most of the power systems part. Okay, the test itself is like a notes for you. Okay, if you take a notes of that question and solution, because detailed solution is given there, if you can mark those, if you can write those, that's will be amazing. Okay, so I mean most of you guys are from Andhra and Telangana, huh? I mean everybody saying AP, Vizag, AC analysis, transient analysis from networks. But yesterday we got many requests saying that, sir, we want, yesterday session was in Telugu, right? So people were saying, our WhatsApp was bombarded with, sir, please do it in either Hindi or English or whatever. So I thought other people are from other places as well, but you're saying everybody's from, Telugu states. I see no one here from other states, but yesterday the bombardment was so high though that, I don't know, maybe they're watching in the rebroadcast, I think. I don't know. If possible, cover on YouTube. See, sir, 600 questions are there. 600 questions are there. In YouTube, it's tough in a single shot, and on YouTube, it's there. It's not that it's not there. If it is not there on YouTube, tell me, I'll cover it. People have done this, man. I mean, some faculty are there. They have done a CL Vadva questions. I think multiple faculties are there who has done YouTube sessions. Okay, if you want, we can share the links as well with you. Yeah. Okay, guys. Gopal Krishna is from Amalapuram. Ante Amalapuram. Okay, guys. I think that's end of the day. Shall we wind up? Bye-bye.